Now, let's look at two random experiments. First one, I call this is random experiment 1. Okay? What is the first random experiment? Say we flip a FAIR coin 3 times. Okay? Flip a FAIR coin 3 times. And we are interested in X. And what is X? X is a number of heads resulting. Number of the heads resulting, okay? So, what are the possible value of X? Possible value of X are 0, 1, 2, and 3, okay? Possible value of X are 0, 1, 2, and 3. Now, how likely X equal to 0? X equal to 0, that is to say we get 3 tails in a row. Tail, tail, and tail. 3 tails in a row. How likely we get a tail on the first flip? Since it's a FAIR coin, the chance is 50%. Same argument applied to the second flip, still 50%. And third one, still 50%. And by multiplication rule, 1/2 times 1/2 times 1/2. So this is 1/8. Okay, this is 1/8. Next, X equal to 1. Okay, X equal to 1. Number of heads resulting is 1. We see only 1 head. 1 head, that means we see 2 tails. So 3 possible outcomes. Head, tail, tail. Plus, tail, head, tail. Plus, tail, tail, head. Okay? 3 heads in a row. Now, if I apply the same argument again, to get a head is 50%. To get second head is still 50%. Get the third or first tail is 50%, second tail is 50%. Third one is the head, still 50%. So, look at here. To get a tail, chance is 50%. And it happens 2 times. By multiplication rule, is 1/2 to the power 2. And tail and 1 head. Chance of getting heads is what? Is 1. No, the chance of getting heads is 1/2. And how many heads we see? We only see 1 head. Okay? But how much such possible outcomes? We see what? 3 different ways you can get only 1 head. Either you see head on the first flip, or you see head on the second flip, or you see head on the last flip. So there are 3 possible outcomes. So the resulting probability is 3/8. Okay? Similarly, we can argue that probability X equal to 2. Okay? Either we see what? A head on the last flip. A head on the last flip means the first 2 flips we see tail. Or we see a head on the middle flip. Okay? Or we see a head on the first flip. And the other 2 flips are tails. So by a similar argument, this is also 3/8. Okay? Also 3/8. And probability X equal to 3, That is 3 heads in a row. Head, head, head. 3 heads in a row. Each one with 50% chance to get it. So by multiplication rule, this is 1 over 8. Okay, this is 1 over 8. So the P and F of X, the probability mass function, this is a distribution function for what? This is a distribution function for a discrete random variable. Can be written as x and px. X, 0, 1, 2, and 3. Okay? Now, x equal to 0, as we have discussed already. X equal to 0 is 1 over 8. X equal to 1 is 3 over 8. Okay? X equal to 2 is 3 over 8. And x equal to 3 is 1 over 8. So let me copy it one by one. This is 1 over 8. This is 3 over 8. This is 3 over 8. And last one is 1 over 8. Okay? Now, probability mass function is used for a discrete random variable to show the distribution. When we say distribution, okay? Distribution. There are 2 information need to be specified. Okay? One, you need to tell me what are the possible value. Possible value of x. And how often or how likely you see them. Okay? Px show us how likely or how often we see these possible values. Okay?